Thank you. So in a multi-track conference, I would typically say, wow, how awesome to see so many people excited to learn about running SQLite in production. But I recognize that you're all stuck with me. But I'm hoping that by the end of this talk, you will actually genuinely be excited about the potential of running SQLite in production. So to start, let me reintroduce myself. My name is Steven. You can find me on Twitter @FractaledMind. And as Lukasz said, I am an American living in Germany. I've been in Germany 5 years, and 4 weeks ago, my wife and I got married, but it was a bit of an international adventure. Thank you, thank you. It turned into an international adventure. We both live in Germany, but neither of us are German citizens, and German bureaucracy made it actually functionally impossible for us to get a marriage license in Germany. So we ended up having to take a train north to Denmark to get a marriage license. But none of our friends or family could come to Denmark, so we then planned a destination wedding in Jamaica so that we could have some friends and family around. In order to get to Jamaica, we had to fly through New York, so we went ahead and had our photo shoot in New York. We finally made it back to Berlin. We are now legally married, and we've had the ceremony. It only took 4 countries. We live in Berlin with our 2 dogs, Ruby and Tuck. I think they bear a striking resemblance to the 2 dog emojis, but that might just be luck. At my day job, I'm the head of engineering at Test.io. That is a crowd-driven quality assurance testing company. And in my free time, I'm an open source developer, contributing to and maintaining a number of gems in the Ruby and Rails ecosystem. And along the way, I write a fair bit on my blog. So what I want to talk about today is why this is how I start all of my new Rails projects, whether those are projects at work or demo apps for blog posts or side projects. And specifically, I want to talk about why I use SQLite as my database engine. And I want to suggest that it might make sense for some of you, some of the time, to choose SQLite as well. And in fact, I want to suggest that it might make sense to use SQLite as the driver for all of your application's persistent data needs, not just to back your models. And whenever I make this suggestion, the first question I get, inevitably, is, why would I do that? Isn't SQLite for toy applications? Isn't it just for running local tests faster? And while it certainly isn't just for toy applications, I do think that that is a fair question. And I'm actually curious to hear from you all, like, what are some of the reasons that you have hesitated or thought, that seems risky to run SQLite in production? And you can just shout out some thoughts, like, why have you not used it? Just a single node. Fair point. What else? Cloud hosting. Okay. Already have Postgres? Yeah, we've gotten used to Postgres. Very true. So I want to address some of these concerns, some of these realities over the course of the next few minutes. I want to start off, though, by addressing one of the most common reasons why people think SQLite can't possibly be production-grade software. And that is the fact that it only supports linear writes. Right? And this is a true fact. You can only have one write operation at a time on SQLite. But does that really mean that it can't possibly be used in production? And I think that, obviously, I think that the answer is no, but I want to dig into why. And the most important sort of insight is to step back and consider how many linearly ordered write operations can SQLite perform in the same amount of time that Postgres would perform one write operation. Right? And let's get a sense of like the difference that we're looking at. And luckily, I don't need to do this work. Ben Johnson, the creator of Lightstream, who's now working at Fly.io, did some benchmarking for a conference talk he gave at GopherCon in 2021, looking at running Postgres in 3 different contexts, right? And what you can see is even when you're running Postgres, that process on the same machine as your application, just the overhead of cross-process communication means that you could run 10 SQLite writes in the same amount of time that you could run 1 Postgres. Now, of course, it's not very common for Rails applications in production to self-host and self-manage their own Postgres on the same machine as their application on that single node. Typically, you're going to have Postgres running on a separate machine, its own machine. If that is in the same availability zone as your application, that's already twice as slow to 3 times as slow to just running it locally. So we're at about 20 to 30 SQLite writes. If that Postgres instance is in the same region as your application, that is about 3 times slower, so maybe 60 writes. But of course, the most common situation today and the most marketed solution, right, is like you need to use a cloud-hosted, managed database service. And odds are, in that instance, your Postgres server will be in a different region than your application. And if you have your application spread out across multiple regions, definitionally, at least almost all of them except for maybe one will be in a different region. And even if those 2 regions are neighbors, so here this is looking at US East 1 and US East 2, we see, latency. You could run 1,000 SQLite write operations in the same amount of time that your Postgres is running 1. So sure, yes, SQLite only supports linear writes, but you can pack a lot of linearly ordered writes in the same amount of time that you make your call to crunchy data or planet scale or what have you. Now, I don't want to spend all of this time talking about the reasons why you aren't using SQLite. I want to spend some time talking about why I think you should. And I'm sure many of you have seen the growing articles about surprise cloud bills. Somebody wakes up one day, checks their dashboard, and like, whoops, I don't have $20,000. While SQLite is one of the cheapest databases in the world because it's free, even just running it is quite cheap. But I think more importantly, the cost is incredibly stable and incredibly predictable. That's a nice bonus. And for those managed database services, we are seeing that they are dropping their free tiers left and right. It is harder and harder to start a side project where you definitely don't have any revenue and be able to get a high-quality, performant, cloud-based managed database service for free. And in fact, one of the last generous free tiers in the managed database space is Terso, which is managed cloud SQLite. And they've talked a lot about why the nature of SQLite and its predictable and low-cost nature is what allows them to have a generous free tier. And more people are starting to see this, right? It's not just in the Rails community. People are beginning to see that SQLite really does make sense as a part of your application stack for running production web applications. And as more and more people experiment with it and give it a chance, they are finding that, yes, it is capable of handling production-grade load. In his Rails World keynote, DHH re-emphasized the fact that Rails at its core is conceptually focused on being that one-person framework, right? It's aimed at making it possible for the smallest possible team, right, just you as a full-stack developer and an idea, to build feature-rich, valuable applications. And I think SQLite is uniquely aligned with that vision. for me, I think there are three reasons why, right? That Rails is the one-person framework and SQLite maybe has like the one-person database engine make good bedfellows. And the first is simplicity, right? Your database is literally just a file on disk. Your database engine is a single executable that runs inside of your applications process. And that simplicity drives a unique amount of control because you can embed every single aspect of your database, the engine, its configuration, into your repository. And this control unlocks some unique developer experiences, right? Whether that's branch-specific databases, whether that is controlling the actual compilation flags to tweak the nature of the SQLite executable. You can do that just through Bundler. You have the opportunity to have an experience that is actually akin to Docker, but without the need to actually run Docker, right? Like I have multiple applications. I'm not using Docker, but I have everything I need in my Git repository. I git push main, my CI builds that on production. Everything lives inside of the repository. And then, of course, naturally, SQLite is fast, right? We've seen it can be 1,000 times faster than cloud-driven Postgres. And that speed is hard to really wrap your mind around the kind of freedom that it gives you until you try it out, right? There's a sort of famous/infamous part of the SQLite docs that say, when you're using SQLite, you should probably not prematurely optimize away N+1 queries. They have a whole section about it. And it sounds heretical, but it actually makes sense in certain contexts, and it's something that SQLite makes possible. So why do I choose SQLite? I choose SQLite because it allows me to build feature-rich, valuable, fast applications quickly, to maintain them easily, and to have them running in production both resiliently and performantly. And at this point, I'm curious just to get a sense, does anyone here actually have an application running in production using SQLite for any purpose? Yeah. Sure, if it gets me a hand, then it counts. Right, and this is to be expected. So what I want to do now is I want to turn to the practical, and I want to talk about how can you actually make this work? How can you get an application in production that's running performantly, that runs resiliently? Like, what are the steps that you need to take? What does it look like? So that we can all end this session feeling comfortable and confident that I could go and I could start a new application, I could use SQLite, I could get it in production, it would work well, I understand what's happening. So, how do we do it? Well, I need to be honest with you at the outset. Unfortunately, right now, today, running SQLite on Rails, out of the box, if you use that command from before, Rails new database SQLite, that isn't viable. You are going to have problems. It won't be as performant as you want. It won't be as resilient as you want. And you're going to be like, damn that Steven guy, he really screwed me. Now, it's my personal goal for Rails 8 to make this statement true, to allow you to run Rails new, and the out-of-the-box experience is production ready, and there's nothing else that you need to do. But that just isn't true today. And I'm not going to hide that from you. I'm not trying to shill for big SQLite. But that doesn't mean that it isn't possible to get there. So let's talk about the steps that are necessary, why they're necessary, and what it looks like to make the production experience viable. So these are the steps. It's pretty complicated. You're going to want to add the enhanced adapter gem. This is a gem that I have written. And that's going to give you performance. Okay. Then you're going to want to add the Lightstream gem. This is a wrapper for the Lightstream utility. That's going to give you point-in-time backups. That's resilience. You're going to want to run the installer for Lightstream. So 3 CLI commands. If you want to see more of those QR codes, you've got the GitHub repos, some blog posts talking more about them. Thank you. I had a really great time. I hope you did too. Now you know how and why to run SQLite in production. Okay, to be fair, I do have 100 more slides. That is, though, the takeaway. So if I lose your attention for the rest of the time, that's okay. I understand. It's the morning. I'm trying my best, but I have self-diagnosed ADHD too. I understand the struggle. I want to take the time, though, to really dig into what these gems are doing. And today, specifically, I'm going to walk through what the enhanced adapter gem is doing to ensure that our applications are going to work performantly. Right? So I'm going to really dig deep on performance because there are a number of problems, and we are solving them automatically for you in the gem, but it's doing some magic, and I want to make sure that we're all on the same page about like what is happening, what the problems are, what the solutions are, and how we were able to wrap them up in a gem that you can just run bundle add. Okay. So as a foundation for this journey, I made a Rails application. This is Lorem News. It is a basic Hacker News clone. You have users that can make posts and comments, and all of the content is lorem ipsum. In the original version of this talk, I was going to do a lot more live coding, but I'm not that good with one hand. So last night I went and took a bunch of screenshots, and we're just going to sort of look at the code on slides. But it's all up on GitHub. I'll get the repository information out shortly. So to start, I am going to run it on my local machine in the Rails env production mode. And I'm going to use this load testing CLI utility to simulate load, and we're going to use that to sort of drive our investigations, like where the pain points are, and then we're going to figure out how to resolve those pain points. So if we start running it, I have this benchmarking controller, which just simulates a lot of the standard CRUD actions, right? So you can create a post, you can create a comment, you can go to the post index view, you can go to the post show view. We're going to hit post create, right? We're going to hit a write endpoint because this is where SQLite's bottleneck lies. We're going to start off sending concurrency of 1, right? So just a wave of 1 request after another for 5 seconds. And when we do that, oh hey, things look pretty good. Not too bad. We've got all 3 O2s, decent stats. Things look nice. Maybe I was wrong. Maybe it is viable. Well, of course it isn't. If we bump that concurrency up to just 4, so we're going to send waves of 4 requests at a time to our server, we're going to see, some 500s. Right? So this is the first problem. This is what you're going to see. If you just take Rails New, you put it up on the internet, you're going to get a lot of reports in your error monitoring service, 500s. We go back and we look in the logs and see what are these 500s? What's happening? We're going to see the dreaded, for those of us who run SQLite in production, the dreaded SQLite 3 busy exception. This is the bane of my existence. All right. And this is the error that is thrown when your database is locked. Right? So as we said, SQLite only supports linear writes. And in order to ensure that only one write operation happens at a time, it has a locking mechanism. Right? So if one connection acquires the lock and begins performing a write operation, while that write operation is occurring, if another connection comes in and says, ooh, I need to write to the database says, I'm busy. Come back later. Now, it doesn't actually do that for every single operation, though. It has a queuing mechanism, and you have a timeout, and you can set that. But we're still getting, in this case, 20 plus busy exceptions. So what's the problem here, and how do we fix it? Well, I'm going to start with how we fix it, and we're going to work backwards to the problem. Just to give you a sense of the scope of the problem, as we double our load, right? And just for reference, I didn't add this slide as I was transferring over from live coding to showing a bunch of slides. My machine has it's a M1 MacBook, has 10 cores, so I'm running with web concurrency of 10. So I'm spinning up 10 Puma workers. So this jump from 8 to 16 is a notable jump because there the amount of load that we are putting on the server is greater than the amount of Puma workers that we have. And that'll become more relevant later. I forgot to add that slide. But we see, right, like our percentage of errors, how many of our requests return error responses, jumps up over 50% as we get concurrent load. This is obviously a production level disaster, right? This is not production rate software. So the solution is immediate transactions. So let me give a little bit of context what the hell this means. Because SQLite only supports linear writes, it has to support two different behaviors for transactions, right? And the terminology that it uses is deferred and immediate transactions. So if you're looking at a transaction, the default behavior, so you don't specify anything explicitly, is deferred mode. And what deferred mode means is that it's not going to attempt, this connection is not going to attempt to acquire the write lock until a write operation is seen inside of that transaction. So SQLite basically presumes that transactions are going to be read-only until it sees an actual write transaction. So begin transaction comes in, no need to acquire the write lock. Select star comes in, no need. Select star comes in, no need. It sees update users, okay, now I need to acquire the write lock. And the problem here is that because SQLite needs to keep its isolation guarantees, if it retries this update inside of this transaction, it's going to get a different snapshot of the database. And it can't guarantee that that snapshot was the same as the snapshot when the transaction started, right? So it has to immediately error. This default makes sense for the context that SQLite was originally built for. We have one connection, and maybe you have a high degree of transactions that are read-only, right? It's like avoid the overhead of acquiring the write lock. But for our Rails applications, this is a terrible default because Rails is going to wrap every single write operation that it runs in a transaction. When we write transactions, we're basically guaranteed to have a write operation somewhere in there. So read-only transactions are incredibly rare, and we are going to have multiple connections to the database. Active Record has a connection pool. By default, it'll have 5 connections in that pool. This is always going to be throwing errors for us. So what we need in the Rails context, transactions are always right. So what we need is to ensure that we attempt to acquire the write lock when we begin the transaction. And this will allow the retry mechanism that is built into SQLite to actually have some effect. Because we can retry this begin statement. This is just trying to grab a snapshot, right? It's like, can I get a snapshot now? No. Okay, I'll wait. How about now? No, I'll wait. How about now? Okay, perfect. Now I will begin, and then everything inside of it can run successfully. So this is the solution to our problem, conceptually. How do we actually bring this into our Rails application? Well, it's luckily pretty easy. Since version 1.6.9 of the SQLite 3 Ruby gem, which is the driver that connects Ruby to SQLite, you can actually set the default transaction mode. And since Rails will pass any of the top-level keys in your database YAML straight to the database initializer in the gem, you can just set default transaction mode to immediate. And all of the transactions that Rails spins up are going to now be immediate mode transactions, not deferred mode transactions. And we're not going to see these 500s. We can validate that. We can run our load tests. And we'll see a much more beautiful graph. Now, at 16, we start to see, we still got some errors. This is a signal that we're not quite done. We're not quite at production-ready software. What's the next problem? Well, if we dig into our latency, we start to get a sense of what the problem is. So here we're looking at the P95 and P99 latency as we increase concurrency. And we see at 16 concurrent requests, right? And this is where we jump over the number of Puma workers that we have. Some of our requests are taking over 5 seconds. When we get to 32 concurrent requests, it pushes down to the P95, right? More than 5 seconds. And if that 5-second number is ringing a bell, it's because in the last slide we saw we have this timeout. This is what Rails new is going to generate in your database YAML for you. And this is setting the maximum amount of time that a query can try to acquire the write lock. And if it takes longer than this, it's going to throw that SQLite busy exception after 5 seconds instead of immediately, which was our problem with with deferred transactions. So clearly what's happening here is that we have some queries that are trying to acquire a lock the whole time, can't ever acquire it, eventually throw an error. So this configuration is getting converted into this SQLite command, right? Pragmas are how SQLite allows you to configure your connection. And SQLite comes with this busy timeout pragma, and it just takes a number of milliseconds. This is how long your connection can attempt to reacquire the write lock before it will throw the busy exception. And the problem we have here is some of our connections, some of our requests and the connections that they get are taking longer than this timeout. But we saw before, right? This is a simple write query. It should take microseconds. Why are we having any of them take more than 5 seconds? To understand that, we have to understand how SQLite and Ruby interact. Rewind. First, let's understand how the retry mechanism works. So if you get 4 concurrent queries sent into SQLite, one of them is going to acquire the write lock, and the other 3 are going to stay queued. After the first one finishes, you'll get 1 acquire the write lock, the other 2 stay queued. Right? They sort of have this queuing system built into SQLite directly, and it'll figure out what is the linear order that these operations are going to run in. And this is actually super useful, that this all lives in SQLite. You don't have to write this queuing logic in your application. But the problem for us is that because SQLite runs as an embedded database inside of your application, it actually runs inside of your application's process. In the context of Ruby, with the global VM lock, we have to really be attentive to how we work with an embedded database. Because if we aren't really careful, we're going to have this situation, which is that our I/O working with the database is embedded inside of our Ruby process. It's not really seen as distinct I/O, like I'm talking to another process. And so while we are waiting for the database to actually come back and do something, Ruby continues to wait, and the VM lock is continued to be held. So the fact that we have 2 Puma workers here isn't helping. We're not getting any concurrency. They're not able to mix Ruby and external I/O because it's not seen as external I/O. It's seen as internal I/O. What we want is we want to be able to intermix Ruby work with not Ruby work, right? And SQLite work is not Ruby work. We should treat it as external I/O and allow us to actually have concurrency where we can have multiple Puma workers picking up requests as they're doing their Ruby work. SQLite can be doing its work, and they can swap back and forth. So how do we achieve this? Well, we're going to need to make use of the lower level tool that is driving the busy timeout. SQLite has this C API. You can set a busy handler. This is the callback that's going to be run whenever your connection tries to acquire the write lock and it can't. Right? So you can define your own callback. SQLite's busy timeout is just the one already implemented callback function. This is what the logic of SQLite's busy timeout looks like in Ruby. And we're actually going to step through it in just a bit step by step, so we don't have to study it too closely. The key point, though, is like if we implement it in Ruby, instead of using SQLite's C function, we can use the sleep method. And Ruby's sleep method is going to release the GVL. Right? And this is going to allow us to get to that diagram we had before where Ruby work is separate from database work. So if we put this into our application, right, we can just use an initializer and patch how Active Record configures SQLite. When we run our load test again, we see a flat graph. Right? This is what we want. We do not want to see any requests taking more than 5 seconds, right? We don't want to have this internal I/O blocking other Puma workers from even doing any sort of web processing. But we're still not, I think, at fully production-grade software. We see a bit of a stair step here. If we dig in deeper to like our 4 nines of latency distribution, we still see a stair step, right? I want to keep these graphs flat. I think production-grade software, we're really going to strive for aggressive, thoughtful performance. And even at 4 nines, I think we can do better. So what's the problem here, and how can we solve it? Well, the problem is in our busy timeout. SQLite's native, or its algorithm for how to handle queuing these queries up penalizes older queries. And to understand what I mean by that, I want to walk through 3 scenarios of calling this busy timeout, right? So if we think about when it's called the very first time, count to 0. When count to 0, that's less than the size of our array, which is 12. So we're going to enter the if block. We're going to get that first item from our delays array. So we're going to delay for 1 millisecond. We want to compute how long has this query already been delayed. Well, this is the first time, so it's going to be 0. That computation is just grab everything in the array up to that point and sum them up. We add those 2 things up, see if they're greater than the timeout. Our timeout is 5,000 milliseconds as a reminder. 1 plus 0 is not greater than 5,000. So we're going to sleep for 1 millisecond. Let's think about what happens the 10th time. The 10th time this query runs the callback, 10 is still less than 12, so we're going to stay inside of our if block. We're going to get the 10th item out of our array, and that's 50. We sum up all of the items up to 50. That's 178. So it's going to wait 50 milliseconds. To this point, it has waited 178 milliseconds. The sum of those is not greater than 5,000, so we're going to keep sleeping for 50 milliseconds. If we imagine the 58th time, this is greater than 12, so we're going to jump down to the else block. And what we see in the else block is that once we're past the 12th iteration, we're just going to always wait 100 milliseconds. The sum, a little bit different, right? We're going to take the full sum of the array, figure out how many times have we run more than 12, take that, multiply by 100. That gives us our total amount that we've waited thus far. In this case, 4,928 milliseconds. We add those 2 things up. That is greater than 5,000. So at this point, we're going to raise the busy exception. Okay, so this is how SQLite, if you go and read their C code, this is what their busy timeout is doing. We just implemented it in Ruby so we could use sleep. The problem here, and we can just look at this delays array, is that as we back off, if a query starts waiting 3-4 times, it's waiting a fair amount of time before it even tries to acquire the write lock. And to see how this is problematic, how this penalizes older queries, let's go back to looking at our queued up queries and consider one change to the scenario. So first one acquires the write lock. The other 3 are queued. They've tried once, and they're going to wait to try again. One of them acquires, best case scenario, we're just going to increment our count by 1. In reality, these are probably going to jump 2 or 3 steps each time. All right, we get to the next one. So at this point, the last queued query is on its 3rd retry. And if you recall from our array, that means it's going to wait 10 milliseconds before it tries to acquire the write lock again. And let's imagine at this moment right now, a new write query comes in. It hasn't attempted to acquire the write lock at all. It comes in, it's like, I need to do work. Can I have the write lock? SQLite says no. Okay, I'll try again. 0th time, it's going to wait 1 millisecond. It waits a millisecond, tries again. Hey, I need to do work. Can I acquire the write lock? No, still, this query is a longer running query. Okay, I'll wait. First time, it's going to wait 2 milliseconds. It waits 2 milliseconds. Hey, I really need to do my work. This query that was only on its 3rd generation, right, waiting 10 milliseconds, isn't even going to attempt to acquire the write lock before the new query gets 3 opportunities to reacquire it. And as we get further into this delay array, right, we see it only gets worse. So if you have a steady stream of writes, right, new writes are coming in regularly, as soon as a query becomes 3 generations old, it's statistically very likely to be 12, 13, 20 generations old. And now you have this latency, just like sitting there waiting for 100 milliseconds, and all of the new queries, they get to acquire the write lock. They're waiting 1, 2 milliseconds. So any query that gets a little bit old is going to get very old, and that's going to push our long tail performance. All right, so what we want to flatten out that P999 graph is to make our retry mechanism fair. Well, that's easy enough. Now that we understand what's happening, let's just make every query wait 1 millisecond before it retries the write lock. Right? We're going to presume that we're going to have a high degree of write frequency, and we're going to treat them all the same. Now, if we treat them all the same, we don't need all of this logic with the delays array and how we're going to sum stuff up. We can simplify this whole callback, and we could just write it like this. And in fact, this is the code that is now in the SQLite 3 main branch. It's not yet in a point release. Hopefully that point release will come out soon. As soon as it does, we're going to put a pull request into Rails to map that timeout configuration variable in your database YAML to this, the non-blocking fair timeout, instead of the blocking unfair timeout that SQLite has. Right, so work in progress, but this logic is in SQLite now. It'll be in Rails by Rails 8, hopefully. And this, with a fair sleep, flattens out our P999 latency graph, right? Now this looks good. Flat. Our queries are being treated fair. This I feel like is pretty production grade software. So when we look at performance, I think there are really 4 keys when it comes to running a SQLite on Rails applications performantly. You want to use immediate transactions. You want to ensure that your timeout mechanism, right, the mechanism for queuing up queries as they wait for the write lock, doesn't block the GVL. You want to ensure that your retry interval is fair. And fourthly, you want to ensure that you're in write-ahead logging journal mode. I haven't talked about the fourth one. And the reason why is that that is already in Rails. Right? So as of version 7.1, these are the new default configurations for SQLite. And if you want to read more on like why these 6 and what they do and how they're going to make your application more resilient and more performant, I have a whole blog post on how we came to these new configurations for Rails. But the key point here is that the journal mode is wall, write-ahead log. And the point here is that by default, originally, SQLite used a journal mode that actually had reads and writes both contend with each other. So you could only have one operation at a time, whether it be read or write. Write-ahead log mode allows you to have multiple concurrent reads while you only have one write. So you could have 15 reads happening as you have your one stream of writes. And that actually brings me to the 5th point. I don't think that this is necessary for production-grade SQLite on Rails application, but I've been thinking about it for a while, and I finally figured out how to do it, and I wanted to talk to you all about it because, to be honest, I'm just excited. If you think about write-ahead log mode and the fact that you can have multiple concurrent reads with your linear writes, you might start to feel, well, Rails is kind of screwing me a little bit. Because the connection pool doesn't know about the difference between reads and write queries, right? It's just like picking up connections. So if we imagine like 5 queries come in, we've got 3 writes and 2 reads. What happens if we have a connection pool with 3 connections? And the 3 connections that get picked up are writes. Okay? Well, SQLite could run those read queries while these write queries are happening. But Rails is got a saturated connection pool. It is going to have to, these read queries are going to have to wait to get a connection from the active record connection pool, which means they're going to have to wait for these writes, the first write to finish up before one of them can come in. And of course, we know that these writes are only going to be resolved one at a time, linear writes. So the nature of active record is actually holding us back from as performant a SQLite on Rails application as we could have. If we wanted something more performant, ideally, we would want to isolate those connection pools. We want to have one connection pool for reads and one connection pool for writes. And that way we never saturate the connection pool for reads with our writes. And I spent a couple of months in the back of my head trying to think, how could I actually get Rails to do this? And I figured it out. And I want to talk about how we do it. And we're going to use active record support for multiple databases. So, as you might remember, if you have read the Rails guide on multiple databases, you can define a 3-tiered database configuration file. Right? And when you do that, you're just telling Rails, I want to set up some new databases. And in all of the docs, what they talk about in the mental model that they have is like, I actually want to talk to physically separate databases. I've got my primary and my replica. This is the classic example that you're going to find in the guides. But there's nothing about the actual implementation that requires that. You could just as easily point 2 different named connection configurations to the same physical database. It could be SQLite, it could be Postgres, it could be anything. Active Record doesn't care. So in this example, we're just going to create a reader configuration and a writer configuration. They're both going to point to the same file on disk, but we're going to tweak their configuration just a little bit. Right? So for our reader, we're going to ensure that every single connection that is created inside of this connection pool is a read-only connection. Right? This is a flag that you can pass down to SQLite when it spins up a new connection, and it tells SQLite from the beginning, oh, I only expect to do reads. It'll throw errors if you try to do writes. And because of that, it can optimize some of its internals. Then for our writer connection pool, we're going to say, I only want one connection, right? We can only do linear writes. Let's move the locking up from SQLite into Active Record. And that's going to be beneficial to us because SQLite has to use a file-based lock. And an in-memory lock, just like I don't have a connection free, wait to get one, is just going to be a bit faster. So once we have this new configuration, we're just going to follow the Rails guide still. We've got to tell our application record how to map these new configurations to the writing and reading role. Easy enough. The writing role will use the writer connection, and the reading role will use the reader connection. I try to be creative in my naming. Once we have set this up, you might think, because I did think, perfect, I'm done. Active Record knows about my roles, and it'll know if I call select on my post record, I want to do a reading operation. It'll use my reading connection. I do insert on my post record, it'll know. Right? Unfortunately, no. Active Record, there's no magic there. This is just some configuration. You have to manually tell Active Record which connection to use for your operations. To do that, you, I think, are going to want to do something that I conceived of as deferred requests. It's like deferred transactions at the level of web requests, right? We want to presume that every web request is a read-only web request, like use our reader connection. And inside of that web request, whenever it needs to make a write, like we call post.create, for that one operation, let's switch into our writer connection pool, use it for that one operation, and then fall back to the reader, right? So to get this to work, we're going to need to use the automatic switching that Rails has for multiple databases. So they have an initializer or a generator you can run, which will create an initializer. And we're going to tweak it some. This is the tweaked version. You basically have 3 things that you configure. So there's this database selector delay. By default, you're going to see 2 seconds. The original default implementation with the primary and a replica, in the guides they talk about, we want to ensure that we're always reading our same write. So they have this delay there to say, if a request comes in and it's a post, and so we switch over to our primary, and then immediately thereafter the same user makes a GET request. Let's go ahead and keep talking to the primary and not switch over to the replica. And that way we don't have to deal with replication lag. We'll just ensure you're reading that same data. We don't need to mess with any of that because we're talking to the same database, right? There's no difference. These are just connection pools that we're spinning up. We want to use a custom resolver. You can read the details of a resolver, but the core point and the one thing we want to patch is how do we determine whether a request is a reading request or not? By default, it's going to say header get requests. Our reading requests, everything else is a write request, so replica or primary. We want every web request to go to our reader connection pool, right? These are our deferred request setup. So we'll just set that to true. Resolver context, that's just where it's going to store the last write, and it uses that for determining if you're within the delay window. We don't need any of it, but it has to be set up, so we'll just use the default. So what this is going to do is this is going to point every single web request, is going to wrap it in a connected to block that points it to our reader connection pool. So that's good, but how do we get our writes, the write operations inside of those requests to actually switch to the writer? Well, unfortunately, we have to patch Active Record. I really wish that we didn't. I would love to figure out how to tweak Active Record to not make this require a patch, and I'm thinking about that and working on that, and maybe I'll be able to get that into Rails at some point. But for now, we have to patch it. But I think we can do it pretty lean. Right? So if we patch the transaction method, you can dig into Rails source like I have. I'm pretty sure this is all we need to do. I'm not 100% sure because I haven't read every single line of Rails. I won't lie to you. So I call this experimental. But I'm pretty sure that all of the write operations, create, insert, update all, what have you, right? They, maybe not update all. They use the transaction. So if we wrap that method in our connected to block and point that to our writing role, and then just call super, for that operation, we're going to explicitly say, use this connection pool. And that'll switch us over. Patching Active Record is pretty easy with prepend, which is nice. And this should give us everything we need for these deferred requests. So by default, the request comes in. We're going to pick the reader connection pool. Whenever we do a write operation, for that, just that operation inside of that request, we'll switch to the writing connection pool. And now we don't have the problem of a saturated connection pool. Now, I ran this comparing the standard setup with all of the performance improvements that we've made thus far with and without these isolated connection pools. And I think it looks good. I'll confess, I don't totally have an explanation for you why. So purple is without. Why is there a jump from 16 to 32? I'm not 100% sure. Maybe there were some errors there. You get higher requests per second if you have errors because they happen really fast and just like blow up. Wasn't able to dig into it a ton last night when I ran this and made these graphs. But what we do see in blue, right, 411, 423, it's a bit faster, and it's consistently fast. So I think that this is a nice feature. I say it's experimental. I haven't yet guaranteed that all we need to do is patch transaction, that every single write operation is going to be there. But I'm going to start trying this out. I'll find the places where it's not quite covering everything. We'll get it to a place where it's as resilient as the other four. But these five, if you wrap them all together, you're going to have a really performant Rails application. So I don't think that every Rails developer should have to know all of this. I hoped that some of you would be interested in this. You know, I've heard about the reputation of Wrocław RB, right? Like this is a place for advanced topics and serious developers. So welcome to the jungle. We dug into Rails. But for most developers, you shouldn't need to mess with all of this. That's why I created the enhanced adapter gem, right? It's going to automatically patch your configuration to bring all of these features into your application automatically. You don't have to do anything. You run bundle add, it's going to set up its own initializers, it's going to patch things correctly. Every single thing that we have walked through is in the gem precisely as I have described it. And if you want to use the new isolated connection pools, as I said, I'm marking it as experimental. I literally figured it out like 4 days ago. And I haven't put it in production myself. And I haven't read every single, so experimental. So I put it behind opt-in configuration. So you have to manually decide you want to turn it on. But it's also in the gem. You don't have to do all of those different configuration points. And beyond that, it's going to bring some other features. It's going to backport some of these active record adapter features that are in Rails main, aren't in a point release or in like a newer point release. So if you're in Rails 7.0 up, you can get deferred foreign keys, right? So if you wanted to set up when you add a reference that it is a deferred foreign key, so you could have circular references like this, You get that. That's in Rails main, not yet in a point release. Also going to give you virtual columns. I remember when this came for Postgres, I was like, awesome. It'd be so cool SQLite had that. I went and looked in SQLite docs. It's like, oh, it's had it for 15 years. Why doesn't Rails have these little keywords to support it? So added that, also in Rails main, not in a point release. Hopefully all of this stuff comes together for Rails 8, but it's in the gem, right? So you bring in the gem, now you can use virtual columns. You also get the ability to set custom return values. And it's going to do the whole feature as it exists now, like for Postgres. So if you have like these virtual columns, they automatically are going to get hydrated on insert. That whole feature is very cool. Also there for SQLite, but not in a point release. It's that story. Also going to give you the ability to set up your Pragma configuration directly in your database YAML. This is also Rails main, not in a release, but a very cool feature if you want to do other configuration. Also allows you to set up extensions through your database configuration as well. So if you add an extension, like in this case, this is an extension for vector similarity search. It's wrapped up in a gem. You can just add the gem, but you need to activate the extension, and it provides an easy hook in your database YAML file for that as well. So the gem brings a lot of various features, just generally enhancing the SQLite 3 adapter. Of course, it's going to bring the fair, non-blocking busy handler for us. As I said, we're bringing this into the SQLite gem itself, and then that's going to get piped into Rails, but that is also work in progress. That's all just in the gem. And of course, our immediate transaction mode. You don't have to do that yourself. You can just run Rails new and bundle add, and all of these things are just there. It doesn't even add it to your database YAML. It's just conceptually that's what it's doing. So you want to have a performant SQLite on Rails app. Those are the 5 keys. You understand how they all work, but you don't need to do any of that work. You can just run the bundle add command. What about resilience? Well, I don't have a lot of time, so we're going to move quickly through resilience. I wanted to go deep on performance. I was into it. I got to just confess that. Just wanted to take the opportunity to really dig in. But there is so much more, right? The future of Rails is leaning into a default world where the database is the foundation for all of our IO-bound components, right? We already have solid cache and solid queue, solid cables being worked on. SQLite is a really wonderful foundation for this new version, new vision of the world, right? You can just spin up separate files. In my apps, I've got cache.SQLite 3, queue.SQLite 3. I look forward to the time I can have my cable.SQLite 3 file. It naturally has the benefit when you just have these separate files. Well, they all get to be concurrent relative to each other, right? Like they all have their own individual write lock. And they're lean and fast and cheap and free. And as a future where out-of-the-box Rails is simple and cheap and easy, SQLite with the solid gems is going to be interesting, if not for everyone exciting. For me, exciting. As I talked about before, you can configure the actual compilation of the SQLite executable through Bundler. This is some really exciting work that Mike D'Alessio and I did earlier in 2023. So you just set the build.SQLite configuration with whatever C flags you want. There's a whole page on the SQLite documentation detailing all of them. This would be my recommended set, just if you want to default for your Rails application. I use this. I would recommend you use this. If you want to read more about why, I have a blog post. Talked a little bit about branch-specific databases. This is a really cool developer experience that I have found, right? So your database is just a file on disk. I don't want to have to deal with, I'm working on a feature branch. One of my colleagues comes in and says, hey, I really would like you to review my branch. I'm like, cool, okay. Check out their branch. I had some migrations in my feature branch. They have some migrations in their feature branch. My Postgres database is now confused. Ah, hell. Well, what I realized pretty early on is like, these database YAML configuration files, they run through the ERB engine. You can throw ERB in them. Inside of ERB, I can run shell commands. Okay, so I can just get my current branch and say that's going to be my database name. And then I just need to ensure that that file actually gets sort of like hydrated with my full database. Well, Rails makes that pretty easy. It's got this active record tasks database task module. You can call your prepare rake task. It'll run your migrations, get everything there. If you've got seeds, it'll run that, right? Get everything set up. So now, every time you switch into a branch, you've got an isolated database, and it'll spin up as soon as you spin up. If you do this after initialize, anytime you spin up your app, so this is your server, your console, you run Rails runner, what have you. I use this all the time. I think it's cool, and it's 2 lines to get that. Resiliency, I really thought about going super deep on it, and it's like, I don't know. Lightstream is awesome, right? It's just going to take every single operation that is put on the wall file, and it's going to stream it to any S3 compatible bucket. That's it. The configuration for it, you just say, here's the URL of my bucket, here are the credentials, here are the paths to the database I want you to watch. There are other alternatives. This is the simplest, this is the most robust. I use it all the time. I will note, if you aren't paying attention, pay attention now. If you're running a database, a Rails application with SQLite as your database, do this. I'm telling you that because, yes, of course, I've deleted my production database. Who hasn't? And it sucked. And I tried to like go into the OS memory and recover the file, and I couldn't. Big pain in my butt. Every app should run this from the beginning. Resiliency is very important, and I put a lot of work into making it stupid simple for Rails applications. We're going to wrap the Go executable. We get all of the configuration mapped into your Rails application. I want this to be easy because it really is important, and nobody else should go through the stress and pain of, whoopsie daisy, that file is gone. And I hope after all of this, you start to have some heart eyes for SQLite. I didn't talk, I'll be fair, I did not talk about single node. Happy to talk about it more. I'll just say one quick point. Single nodes are all right. They get the job done surprisingly well, surprisingly often. If you have an application where you need multiple nodes, okay, maybe SQLite's not the best choice. I'm not trying to say it's a silver bullet. If you have already invested a lot into your SQLite architecture, there are multiple tools to allow you to run SQLite multi-node. That is not an impossibility. The Lightstream utility by Ben Johnson, he's also built the successor to that, LightFS, which is multi-node SQLite, right? So you can do it. I would just recommend that everyone start, if you're starting a new project, like start with this mindset of what is the bare minimum that I can do to build something that is actually an excellent application for users. And you would be surprised how little is needed to write excellent software. Hatchbox makes it really easy to throw an application onto a single node. The speed of light is actually pretty freaking fast. And if you make a really well-architected application and you don't have a lot of bottlenecks and you've made these performance improvements, even 200 milliseconds or whatever, 200, 300 milliseconds around the globe is probably going to allow you to get to revenue. And at that point, you can start to figure out what you want to do. So I really appreciate your attention. I know we went super deep into stuff that is ultimately wrapped up into a gem. I want everything to be easy, but I also wanted everyone to feel like confident about like, oh, I know what these tools are doing. Like it's not just like a black box of dark magic. I really thank you for your time and attention. Attention, right? I get it. But if there are any questions, happy to take some now. And also, of course, happy to have any conversations on any topics over the course of the conference. Thank you.
Thank you for amazing talk. My question is, you talked, 99% of your talk was about performance. About 1% was about resilience. But I haven't heard security word at one time. So I think it should be taught that this whole idea of embedding database inside application process treats security, one of most important security principles, which is isolation, for performance, right? So in case there are some security problems in SQLite, the attack surface is larger, right? So my question is it worth to trade these few microseconds, which is where SQLite is better than Postgres running locally via, for example, Unix socket? Is it worth from the security perspective?
So that's a difficult to answer question objectively. So let me just give some of my thoughts on how I would, some of the considerations. Right? So one is, you mentioned relative to running Postgres locally. And there, I think that there are some key similarities. Often, of course, you're running Postgres on a separate machine. And I do think that it's important to at least note the trade-off there between a single point of security vulnerability as well as a single point to harden your security. Right? So if I have one machine, make sure this machine is protected. We've got two machines, I have to make sure these two machines are protected and they're doing different work and I have to protect them differently and I have to understand those security patterns. So there is a trade-off there, right? Like two machines, they're isolated from each other, but I have to secure both of them. One machine, it's one attack vector, but it's also one hardening surface. As for the difference between Postgres and SQLite on the same machine, in general, my perspective is I want to do the absolute best that I can. I'm looking for the highest leverage choice, right? What is 20% of the effort to give me 80% of the value, and then I'm going to figure out what to do with that other 20%. And if someone has gotten access to my machine, I'm probably hosed, right? So there are certain applications where it's really important to have really strong multiple layers of security. And if you have that kind of application, you should make sure that you're thinking very critically about what architectural decisions do I need to make on day one to ensure that I'm doing that. Does every single application have those characteristics? They don't, right? And for my core thought is that I really want to switch over the mindset for a lot of developers to say, doing your job well does not mean choosing the absolute best tool and technology that is theoretically possible for every single slice of your stack. All right, I did it. Microservices are smart and good, and I need to isolate. Doing your job well is like finding the right set of trade-offs. And for many applications, having a single attack vector that you actually think through how to harden, how do I make this machine on the internet, but secure on the internet, and just learn how to do that well, probably makes sense. And for applications where you really need hardened security, you really need to think through what do you need? Is it going to be a smart trade-off? And that's a whole different conversation and consideration. And maybe SQLite doesn't make sense there, and that's okay.
Thank you. Let's say I'm investing in this approach for my hobby project, and at some point it gets big, and instead of going all into SQLite and investing in for further investigation how to make it running, I just want to switch to Postgres. Is there anything in this approach locking me to SQLite forever, or it is just doable?
Yeah. Short answer is no. Just to add two sentences on top of it. SQLite is simpler and looser than Postgres. And it's generally easier to go from the simple and loose thing to the more complicated and strict thing than it is to go in the opposite direction. So SQLite schema is a looser schema. You can make it like more strict, but it's got less data types, and it's a subset of Postgres's data types. Of course, naturally, if you're in a Rails application and you're using Active Record, you have an intermediary layer naturally already, and that makes it more possible and more likely that you'll be able to switch out databases. At my day job, we actually just finished migrating from MySQL to Postgres across 3 different applications. That was made possible because of Active Record. So there isn't anything in this approach that like locks you in, especially if you're just using the gems, right? Because you don't even have to change the source files. You can just say bundle remove Active Record, and it's not going to patch those configuration files anymore. And the schema itself are, if you're doing some very, very specific stuff, there are some slight differences, but in general, SQLite tends to have a subset of features than Postgres. So it's possible to migrate.
I think that we should finish this Q&A session. Let's continue later on, especially in after party. Sorry, Philip. So once again, thank you, Steven.